All right, today we're going to talk about how to write a polynomial given the zeros or given the solutions. And so a lot of times when we factor, you may get something, you have, x plus 1 times x minus 3. And when we factor, we want to take each individual factor and set it equal to 0. So, and find the solution. And so we would say, x equals a -1, right? It'd be the opposite sign after I subtract 1 from both sides. In the same way here, after I add 3 to both sides, we would say, x equals 3. So the factor is x plus 1, but the solution, or the root, or the 0, is x equals a -1. The factor is x minus 3, but the solution is x equals a +3. We're going to use that same logic here to help us out. We're going to now work backwards. We're going to say, hey, when the solution is 3, my factor is its opposite, x minus 3. We need to know that to find the original polynomial. So here, if I have that x equals a -2, then I need to put that back into its factored form and say that this is x plus 2. And then if x equals a +3, then this would be x minus 3. And if x equals a +4, this would be x minus 4. So from here, all we have to do is distribute this out, and then we would get our original polynomial. We are expecting something that has a degree 3, or x to the 3rd power, right? Because we have 3 solutions here. So it's going to cross the x-axis 3 times. Now, let's go ahead and distribute this out. Don't worry about the x minus 4. Just do the first 2 first, and then we'll take care of the x minus 4. So we have x times x, which gets me x squared, x times the -3, which is a -3x, 2 times x, which is 2x, and then 2 times -3, which is -6. Now, we didn't do anything with this x minus 4, so we're still going to leave that out here. Let's combine like terms. So we have our 2 terms in the middle that are combined. So I get my x squared, -3 plus 2 is a -1x, minus 6, and this is being multiplied to x minus 4. Remember, just go through the same process. You take your first term and multiply that term to every term in the next set of parentheses, and you're going to do that with all 3 terms here in our first set of parentheses. So x squared times x is x to the 3rd power. X squared times -4 is -4x squared. Now we go to our second term. This -x times x is a -x squared. X times a -4 gives me a +4x. And finally, our last term, -6 times x would be -6x. And then finally, negative times negative gives me a +24. From here, our last step is to combine any like terms that we may have. And so notice how x to the 3rd, there is no other x to the 3rd here. So no like terms, so I'm just going to copy that down. So x to the 3rd. We have this minus x squared and minus x squared. I'm sorry, a -4x squared and a -1x squared. So that gives us a -5x squared, so minus 5x squared. We have this +4x and a -6x. When I combine those together, I get a -2x. And then finally, my constant on the end, so plus 24. So my original polynomial, x to the 3rd minus 5x squared minus 2x plus 24, is, after I factor that, I would get down to the 3 roots, or 3 solutions of -2, 3, and 4. So we have an idea of what this graph should look like because it's a +x to the 3rd, and so we know it's going to kind of look like this. But the other thing we know is that if we were to graph this, we have one solution at -2, we have another solution at +3, and another solution at +4. We're going to need to know this information later as we start graphing these polynomials, and more specifically, polynomial inequalities. Let's do the second example. And again, if we're going too fast, you can always pause, rewind, re-listen to my magical voice. And if you're tired and you're having trouble sleeping, play this video. You'll go to sleep guaranteed in 5 minutes. Medically proven, actually. So here, we're given 2 solutions, meaning that this is going to be a quadratic, right? We're going to have a U-shaped or an N-shaped graph. This is going to be a parabola. In our case, that opens up. Now, the reason I wanted to do this is because of the fractions. So let's put this in factored form. So really, we have x plus 1/2, right? And then we have x minus 3/4. So remember, in factored form, we're taking the solution and we're putting it in parentheses, and it's going to carry that opposite sign. What I love about this is that using the Moy's method to factor, as we've done in previous videos, we now know that we can take our denominator and place that out in front, just like we did when we factored using the Moy's method. So because these fractions can't be reduced anymore, you take the denominator and put it out in front of the x. So what we have then is we have 2x plus 1 times 4x minus 3. And again, if we set each of these equal to 0 and solve for x, we would get back to our original -1/2 and positive 3/4. From here, because we only have 2 factors rather than 3, we just have to distribute one time and then we're done. So 2x times 4x gives me 8x squared. 2x times -3 gives me a -6x. 1 times 4x is a positive 4x. And then 1 times -3 is a -3. Last step is to combine any like terms, so I have my 2 terms in the middle. So finally we get that we have 8x squared minus 2x minus 3. And so what we're saying is that we have 2 solutions, which we knew from the beginning, and these 2 solutions are going to cross the x-axis at -0.5 and 0.75. So for example, if we had this U-shaped graph and it crossed the x-axis here, we knew that it would cross somewhere around -1/2 and positive 3/4. So -0.5 and positive 0.75.